Automated Testing Techniques with Christoph Vollmer.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast to deliver software quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure Way methodology. And announcement, my architect forums are going strong, so signups for the next session are now up. We've had several months under our belt, and if you lead a software team and are looking to collaborate with peer architect leaders, you can just go ahead and sign up at the link in the show notes. And for those of you looking for Programming with Palermo, my video podcast, just search in any of the podcast directories or on YouTube, and you'll be able to find it. My guest today on the show is Christoph Vollmer. He is an internationally experienced IT manager with strong experience in software development and team leadership. He's worked several years as a developer with multiple languages in several organizations and industries with different methodologies. He has hands-on experience with a broad range of techniques. He successfully led teams for cross-functional Agile and has a strong focus to deliver the right thing in the right way. He's mentored and managed team members on different levels. He's passionate about Agile and Scrum as a software development methodology because it brings the gap between development teams and business needs. And he has a focus on security, starting at development and going all the way through to the end user and end users' daily lives. And he's also strong with automated testing on every level. So, Christoph, welcome to the show. How are you, sir?
Very good. Thank you very much for the invitation.
Oh, my pleasure. My pleasure. Now, I'll kind of let the listeners know, I have to give you credit just for something personal. You had recommended a typing tutorial for my kids called Mario Teaches Typing that they've actually benefited from. And I'll let the listeners know if they have any kids who are needing to learn typing. I think that's still going, isn't it, Christoph?
Yeah, I think. And glad you liked it. When I think I was at uni and this thing came out and I was not able to do good 10-finger typing. And I saw this, I think, in one of the computer shops, and I thought, oh, might be fun. Tried it out and quickly got very good with it. I had a few issues because special characters were not well supported with the German keyboard at that time. So I did not learn special characters very good, but who needs those anyway? So most of the typing is anyways done with the normal characters. And yeah, it was a lot of fun. It's an enjoyable, gamified way to learn typing. Yeah.
Fantastic. And it looks like it is an old DOS game, but it still runs. Still runs on Windows.
It's an old DOS game, but at that time, when I sent you the email, I found it on a website as a JavaScript. I mean, now everything runs in JavaScript, so yeah. The old DOS games as well. Found it there. Not sure if it's still up, but I'm sure people can find it.
Oh, sure. Now, you are really passionate about testing, and I want to kind of pick your brain and get into that. Mm-hmm. But can you give us a little bit more background? What are some of the high points in your career that kind of led you to really get interested in a deep way in software testing?
Yeah, so my career started in mid-2000, and at that time there was not a lot of testing, let's put it that way. When I got asked to implement a new feature, I did some coding, and then I grabbed a customer database, or 2 or 3. Mm-hmm. Those were the days when you had customer databases on site. And then I tried the new code, and if it worked for me, I made a release, and then the customers tried it, and of course, it didn't work for everyone. So some customers complained. I got a bug report. I needed to fix it, and then went forth and back and forth and back. And Yeah, it was not really enjoyable. I didn't like it a lot. And that was, I guess, my software development for the first 10 years or something. And then I got introduced to automated testing in the way of unit testing. And I thought, wow, that's fantastic. I implement a new feature, I write a test, it works, and I can even be sure that it didn't break anything else. How cool is that?
Right.
And yeah, from then it just went on from the unit testing, which was really just basic unit testing. I learned about the testing pyramid, about the other testing levels. And from there onwards, performance testing, accessibility testing, security testing. And I just realized that I can make my life as a software developer so much easier when I use the right tools and the right frameworks to make sure that the software quality is really good. Then, yeah, life as a developer is just so much better. So I enjoyed that a lot, and I try to learn as much as I can. I try to stay up to date with new trends and libraries via Alvin Ashcraft. He was on your show. And I read his digest daily. It's just a fantastic source of new information. And he has also the section about methodology testing. I think it's the name. And yeah, that's as well how I see new things. For example, things like Stryker or other things, which then help to improve even more in other ways.
Yeah. You mentioned the testing pyramid. I think that's a concept that a lot of listeners and a lot of developers around the industry still, aren't terribly familiar with. Can you give us the high points for the listener? What is the testing pyramid?
Yeah, just very, very quickly, just imagine the pyramid, what a pyramid looks like, and then you make three sections, 3 parts, and the lowest part is unit tests. It is very broad, so it means you have a lot of tests there. Well, all of this is automated testing. First thing, you've got a lot of unit tests in the lower end, so you want to make sure that you have heaps of tests and they are automated, and you can test the business logic that you write. So these are executed very quickly. That's why you can have a lot of them, and you should try to validate all your business logic there. Then in the middle section, you don't have that many tests. You have integration tests there. And this is where you start integrating with other things. So you had also a lot of other great people in your podcast. They talk about integration tests with other systems, mainly, of course, a database, for example. So you have interactions with a database, but you can also have interactions with email server, with storage, with whatever things you might message queue. And this is integrating with at least one other system or maybe multiple systems. And then you're on the top, you've got the UI tests or end-to-end tests, depends a bit on your system. And there you really integrate everything. So this really means end-to-end test having from start to finish all the systems being part of your test. And the reason why we've got it as a pyramid and why we have a lot of unit tests and very few end-to-end tests is because the tests on the top are more brittle. When you integrate everything, you just can have more problems because the configuration might be a problem, a network, whatever. I was, for example, part of a team at some stage, and we had UI tests in the browser, and they broke one day for no good reason. And I got told, yeah, sometimes they are brittle, we just run it again. And they failed 2-3 times. And then we looked into it, and it said timeout, and we were a bit confused. And then we heard, yeah, one of the other teams in the office is downloading DVDs from the head office. That's why the network is so slow. And that was the only reason why the tests broke. So it just shows you these tests are not very reliable. They've got so many moving parts, so you cannot be sure what the real issue is. It can be anything. Can be something is really going wrong. Maybe you did something wrong in your code, but maybe it's just something else. That's why we say testing pyramid, lots of automated, very small tests at the bottom, and just a few that test really the interaction between everything on the top.
Mm-hmm. Yeah, that's a good point. That's a good point. Now, for people who are writing unit tests and integration tests and full system tests, I know from my experience, it was just hearing about one tool here, another tool there for some other people, and then trying out for myself. A lot of time has passed since automated testing has become popular. In your view, when you either start a project or start framing out a new environment for test automation, what are the go-to libraries and tools that are your favorites for use in your automated testing?
Well, it really depends a bit on what you're doing. If you've got a real public customer-facing site, if you've got a real UI, maybe you only have an API, maybe it's only internal, maybe you're really data-driven. It really depends a bit. For example, I talked to some people at one stage and they said, well, we don't have a lot of business logic.
Mm-hmm.
We have a UI, but what we mainly do is read and write data. And then I said, well, then your testing pyramid might not really look like a pyramid. Maybe then it's more like a rectangle
mm-hmm.
or something. But that's okay. So you really need to look at what you really need. Looking at different test frameworks, for example, coming from the .NET background, of course, maybe I should say, there we've got, for example, NUnit, MS Test, XUnit. Those are all great. There as well, you can already start saying, well, I like more this or that. Maybe there is a specific reason to choose one over the other. But again, it depends a bit on details. In general, they are all great.
Mm-hmm.
Looking then how to write the tests, the unit tests or the automated tests themselves, there is, for example, stuff like fluent assertions, which is really fantastic and also very, very feature-rich by now, I would say. I'm still learning new things whenever I look into it. It's like I get a question, well, we've got a problem with this or that unit test, and then I first look into fluent assertions and see if it's got a feature around that. Then you can look into auto fixture, for example, if that helps you to set up the data, or you can look at verify. Of course, mocking substitutes like n substitute, those are fantastic things. Then if you want to improve your tests yourself, then there is things like the Roslyn analyzers, which are available for the different frameworks and also for fluent assertions, for example. I think it was in your podcast at some stage that there was somebody talking about XUnit using the analyzers, which has helped them a lot. Yeah. And then, for example, like I mentioned, Stryker is very interesting as well, because often people talk about test coverage
mm-hmm.
and test coverage being so good and important. But then again, test coverage is a good indicator, but it's not the main thing, because it only tells what are the code paths that got executed. And it doesn't say anything about assertions or validations. It just means executed.
Mm-hmm.
And if, for example, you stress this metric and you set a very high goal there, then people will find a way to fulfill this goal, but it might not be good tests. And then things like Stryker can help you to realize if those are good tests or not.
Well, tell us more about that. And again, for the developers getting into automated testing, what is mutation testing and why would someone want to use it? And then, of course, reach for the appropriate tools.
Yeah. So how automated tests work basically is that you execute your tests, they execute your production code, and then they verify an outcome. So for example, you've got a calculator and you say, I want to try the add function, and then you say 2 and 2 are the two parameters, and you get the result 4. Great, the result is correct. And then you write a lot of these tests and you try to make sure that the different aspects of your production code work well. This can be, like I said, any kind of business logic, like with bank accounts, making sure that people don't withdraw money when there is nothing left on the bank account, or people are over 18 or 21 when they try to apply for something or whatever you've got there.
Mm-hmm.
Then you write tests around that. But the thing is, tests are only as good as the people who think of the tests.
Right.
And you might not have the right idea or not the right experience, or might not have understood how the code can or should be used. And then you don't write good tests. I mean, it happens all the time. You write a lot of good tests and then a bug report comes back. What you normally do is you write a new test, the test fails, and then you write the new code, and then the code gets green, and that's good. But another way to see how good your tests are is mutation testing. So Stryker is one of these mutation testing frameworks. And what mutation testing does is that it takes your production code and your tests, and then it does a mutation on your production code and runs all the tests. So going back to the calculator example, in the add functionality, we've got the plus operator, and then we say parameter 1 plus parameter 2, and then we return the result.
Mm-hmm.
What mutation testing then would do is it would take this operator, the plus, and reverse it into a minus. And then it runs all the tests. So the example would be 2 and 2 are the two parameters, and it would replace the plus with a minus, and then we've got 2 minus 2, and the result is 0, but we expect 4. So then the test would fail, and the mutation would be killed. And that's then a good thing. The test is good because it caught the mutation. That's basically the idea behind mutation testing. And yeah, then you can make it quite complex. So there is, of course, normal operations where there is the opposite, plus is minus, and multiple is division. But then you get into things like link, and then you have take and skip, like opposite functionality.
Mm-hmm.
And if you go further and further, of course, mutation testing can also mutate strings. But then, of course, we get into areas where it's like, yeah, not every string is really important for our production code. Mm-hmm. So you might just do some logging, and then it's not important if the logging string gets changed. That does not have any impact on the production code or the product quality, and then it's not important that the mutation does not get caught. So then you need to do some fine-tuning and tweaking with what do I want to test. But Stryker, for example, has a lot of ways there that you can configure what do you want to test, how much you want to mutate. And yeah, Stryker is fantastic. Now, I think I even saw that it has a baseline feature. So you can do like, okay, I've got a baseline here, and you can run the mutation tests on a new branch and compare it. And yeah, again, fantastic, really fascinating.
Mm-hmm. Okay, awesome. Well, we'll make sure to put a link to Stryker in the show notes, as well as the other tools that we mentioned.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Going back to the build pyramid, you said something that was really interesting to me. I love the way you explain it, but you mentioned unit test and integration test, and then the full system test of the pyramid, but it might not be a pyramid. But you stress writing the unit test and having the however many unit tests are appropriate so that you have a foundation of small tests before you do the other tests. I think, is that how you think of it? As struck to me is regardless of how big the bottom is, it's your foundation for the other testing. Is that how you think of it?
Yeah, I think it makes sense. looking at what the reality is, you might not be there or you might not get there straight away. But the foundation to me is absolutely automated unit tests.
Mm-hmm.
That is, it is easy to write and it runs very reliably.
Yeah.
So that's why it is the base. Yeah. From there, you can add whatever is appropriate again. But yeah.
Now, if you're going into a piece of software that doesn't have a lot of automated tests at all, and you're thinking, how do I add test automation to this software that's been around a long time? What is your thought process to adding in automated testing to legacy code?
Legacy code. There you've got a point, exactly.
Or maybe even if it was well written, it didn't have tests.
Yeah. Well, one of the issues we still or often see is that the architecture does not help you with writing automated tests, at least not on the unit test level. So if you don't have dependency injection, then it's really hard to write good, small automated tests. So then you would need to start to do some refactoring because you can start on that level. Of course, you could go the other way around and say, okay, I start with UI tests or end-to-end tests. So at least I've got some automated tests. It really depends a bit on the product, where the company or the organization is, what their most stressing concern is, what they are after, if they got a lot of issues and they said, we just need to get started with testing. However, then you can start, of course, on the top, but you should make sure that you make your way down and try to refactor and have a lot of small automated unit tests as quickly as possible. And then again, if you touch some code, if you touch a file, try to refactor it, try to introduce unit tests, and that's how it works. I should stress as well, of course, that if there are no bugs, then no need to write tests. Because if nobody mentions there is a bug, no need to write a test. You can say, okay, it is bug-free. As soon as someone says there is a bug, of course, you can start, first write your test, refactor code, fix the bug, and then you can increase your test coverage step by step.
That's interesting. A lot of people who have been educated in test-driven development know the red, green, refactor, and have that drive feature code. But how does test-driven development intersect with production code that's out there that just has a bug report? The feature's already been written. What's the sequence?
Well, if you've got a new feature, of course, I would say as well, try or use TDD. I'm not going to insist you need to do TDD, but I've tried it myself and it has helped me a lot, as well with how you use your code, how you use your interface, how you define your interface, because you start using it straight away. So that is useful. I would go with the TDD cycle then, absolutely, and say, okay, first write your test, make it green, refactor, implement new code, implement the feature step by step. If there is code out there and then you've got a bug report as well, I would say write your test and go over the TDD cycle. But if there is, like I said, features out there that have no bug report, they are out there, they just work, then, well, no need to write a test for it, because then you would spend time and resources and money on writing a test for something that might work perfectly. And then it's always this discussion with the management, well, why do we need to write tests? Do we really need to write tests? Is it not a waste of money and time and resources? And I would say, yes. When I was younger, I would have said, yeah, no, we need to write tests. But by now, I would say, yeah, okay, I understand it. If there is a feature out there and that has no bug reports, no need to write a test. It's perfectly fine. Which then as well brings us back to the test coverage discussion. How far do we want to go with existing code? What is the goal there? Do we need to aim for the 90, 95, 80% something? If there is a lot of code out there and just a handful of bug reports, how do we go about it? Yeah.
I think it's so powerful to use an automated test to reproduce the bug that just got reported in production, to kind of prove that we understand how it happened.
Yeah, absolutely.
Now, there's some movement on the full testing side, and you've mentioned just in our back and forth emails ahead of the show, Playwright as a tool for full system testing. I would like your take on that, but kind of the top of the pyramid, how should listeners think about full system testing and approach that, and where does Playwright fit in?
Yeah, so full system testing really should make sure that, as you say, the full system really works. So all the parts together, the configuration, that everything works, or maybe even with a UI test, you need to make specific tests about layout or UI controls that behave in a specific way, which you can't test in a unit test. Little side note, of course, you can write unit tests for JavaScript frameworks for UI there as well. You can write tests like, okay, if this field is empty, or I've got a controller, and then if this is empty, I get back this or whatever.
Mm-hmm.
But if you want to then really go with the UI, you would write UI tests and make sure that everything works. Of course, don't test everything again. So if you've got the calculator there, going back to the calculator example, let's say you've got a UI, a web UI, and you've got 2 parameters, and you can choose, I want to add these 2 numbers. Don't write a test for something that is already tested in the levels below. That is just, again, a waste of time, money, and resources. But everything that could not be tested in the levels below needs to be tested on the top then, how the full system works, things in the UI, and these things. And yeah, how do you write these tests? There as well, new frameworks evolve, and there is now Playwright from Microsoft. And I haven't written a lot of tests with it, but what caught my eye at some stage was a YouTube video about a new release. I think it's now a few months, was at end of 2022. And in the video, I saw the Visual Studio Code integration. Mm-hmm. And that really caught my eye. And I thought, I need to try that if it's really that easy. And I must say, it was that easy. So within Visual Studio Code, with the extension, you can say, okay, install Playwright. And then you do already get a few examples. And then you can say record test. And then you got a little browser and you click through your UI. And then you've got your code. So this code is not perfect. You need to tweak it. There was something missing. And of course, talking about secrets, you need to do something about that. And we also don't have the page object pattern then. So if you want to make your tests maintainable, of course, again, if you write automated tests, be careful, make them maintainable. You don't want to lose time and money there as well. So writing good test code is as important as good production code. So with the Playwright tools, you do already get quite a few things. That is really nice. And then you just need to tweak it and apply best practices there. But what got me, I had a discussion at that stage that somebody said, oh yeah, we need to get started with these automated UI tests, but yeah, we don't have time. We cannot have 2 people sitting there together, but we've got the domain expert that knows the software, and we've got the developer that knows how to do the coding. Well, I wondered a bit how the developer does not know the product, but let's ignore that for now. And then I said, yeah, well, there is a way, for example, you can just give the domain expert the Playwright tools. They just click through what they think would be good and important test cases. And then the domain expert gives the code to the developer, and they can then clean it up, apply best practices, commit it to the code base, start the automated tests in the pipeline, and yeah, all of these things.
Nice. Yeah, I love the tooling getting so mature in so many of these areas.
Yes, absolutely. And I'm looking forward. I'm sure that we'll get some Visual Studio extensions or support at some stage as well. But what we do already have with Visual Studio Code, that is already fantastic. Yeah.
Mm-hmm. Now, you mentioned just in passing the page object pattern, and I want to dive into that because I think a lot of listeners maybe aren't familiar with it. So what is the page object pattern and how does it fit into UI testing?
Yeah, page object pattern mainly is about writing maintainable code. So as I said, it is important to make sure that your test code follows best practices as well, and it needs to be maintainable. So whenever you change something in your UI, like a word on a button or in the menu or something, you need to make sure that the impact on the test code is as minimal as possible.
Mm-hmm.
And for this, of course, you need to have things like constants and where you reuse things. And one of the things that you then normally do with UI tests is you apply this page object pattern, which means you have an object per page. So you say, I've got an object, well, I've got a page here, and this is represented by an object. And then I, for example, write helper methods there like click a specific button or click on a menu or enter some data. And you can even then apply a fluent pattern there. For example, you can say, enter this data and enter this data, and then push that button. And then would then in the back end with the page object convert to specific things being filled in automatically and specific controls being used and clicked.
I like it so much better than developers just maybe using a CSS selector or combing through XPath or somehow locating an element in order to know where the button is or where the text box is. And then a developer changes something about the HTML or the structure of the page, and now that page is broken because there wasn't a good formal handle by which to actually locate the proper UI control.
Yeah, it also makes code way more readable. If you've got like enter into this field and click button, that is way better to read than reading long strings of, like you said, CSS locators or XPaths or whatever things that confuses people. So It's way better to just read, like I said, even for example, maybe fluent pattern where you just go step by step and then makes it more readable and better to use and to maintain.
Yeah. There's way more in this subject of testing than we can possibly cover in this format. But in your experience, you've done it all. You've done performance testing, security testing, accessibility testing, the chaos engineering. Can you give us just a short primer on these other types of tests and why someone might think that they would be appropriate for their scenario and when they might not be appropriate?
Yeah, let's start, for example, with performance testing. If you've got a product or if you've got a website that is only used internally and there is no spikes, there is predictive load, it's Monday to Friday, it's specific business hours, maybe you are only in 2 or 3 time zones, then if everything works well, you could write a performance test and see, are we going to grow by 10%? Let's make sure that it still works, but then that's basically it. So there is not a lot of need for performance tests. On the other side, if you have a public-facing website and you've got like a shop system, or you've got a specific provider that has specific peaks, then you want to make sure that with these peaks, your website is still working, or even your full system end to end. So It's not only about the website, it's also about backend storage and everything in between. So then you want to do some performance testing and want to make sure that your full system can handle the spike. At least there are other aspects to performance testing as well, like does my system has any memory leaks or things, or maybe it is even sized too big. Maybe I can downsize some of the parts of the system. So all of these things can be done then. Accessibility testing I think should be important to everyone. But yeah, time and again, I see that people say, this is only internal and nobody needs accessibility here, which is a bit sad, because you never know who starts in the company next month or something. And accessibility helps normal users as well. So being able to tap through the controls in the right order, or to use controls with space and return, or maybe have some shortcuts through the website, it helps everyone. And this is also part of the accessibility.
That's a good point. Decades ago, it was normal to be able to fly through software using only buttons on the keyboard. And with the web, it just now everyone's pointing with a mouse and trying to hover on the right button to click. And even if you try to use the keyboard and just tab through, sometimes the tab order is all out of whack. And what I found fascinating is it seems like the same work to implement the page object pattern and get full system testing working well is a big overlap with the work to make the application compatible with screen readers for the blind and other accessibility tools. Yeah. I don't have in-depth experience there, but yeah, it's I would say start from the beginning. Really try to make sure that you add accessibility from the start, because adding accessibility later on is always hard, like a lot of other things. If you want to retrofit it in, it's always hard. Yeah, for sure. And accessibility is I've got passionate about that. I've done some considerable project work in that. More than just, you might think, that they don't have the use of their eyes, or they don't have the full use of their ears or whatnot. But just any kind of alternate keyboard, or even just making your application faster to use with a keyboard. It's a lot of the same work.
Yeah, and like you said, it can be any handicap. It might just be eyes, it might be ears, it might be something with the hand. Maybe they have a shake, or like for example, on my keyboard, I've got only the control key on the left and no control key on the right. So sometimes I see myself, I grab a coffee or something, or I drink something, and then I want to do a specific shortcut with the control key, but the other keys on the other side of the keyboard, and I just can't do it with one hand. So it's not working.
Yeah, we need more coffee-friendly keyboards.
Definitely.
Well, Christoph, man, thank you so much for coming on the show and sharing with us these advanced techniques for automated testing. I really appreciate it. I know the listeners have probably been drinking from the fire hose and have learned quite a lot and have taken quite a few notes. So thank you.
Thank you so much. It's been a pleasure talking to you.
Oh, my pleasure. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.